The first part of the spring break assignment dealt with electric potential, or electric potential difference, or a measure of how much energy per charge an electron got as it flowed through a circuit. The second part dealt with electrical current, or how quickly electrons were flowing through a circuit. This next part is going to deal with the resistance of a certain part of an electrical circuit. And the resistance just kind of deals with how difficult it is for electrons to flow through a certain point or a certain element within a circuit. And again, we're going to continue trying to draw an analogy between things that we kind of have some intuition for, as well as electric circuits. So if you think about ways that you can make an obstacle course more or less difficult, and if you think of yourself running an obstacle course, such as like the Warrior Dash, which is a popular obstacle course race. But if you think of running an obstacle course, one way that you can make an obstacle course more difficult is, this is going to sound kind of self-explanatory, but you can put more obstacles in the way. And if you put more obstacles in the way, it would become more difficult for you to complete the obstacle course. The next way that you can make an obstacle course more difficult is you can make the obstacle course longer. Running an obstacle course that was 1 mile long is a whole lot easier than running an obstacle course that's 10 miles long, so increasing the length would make the obstacle course more difficult to run through. The last one's a little bit kind of tricky, but for the last one, when I did one of these obstacle course runs, if like here was a wall that I had to jump over, and this was me kind of running, if there was a way for me to run and just zigzag around the wall, I would do that because I'm kind of lazy and I don't like to jump over walls unless I have to. So if you think of something that you could do to, and this is a top view of the obstacle course, if you think of something you could do to the obstacle course to make it so people have to go over the wall, is you could take the course and you could actually make the course a little bit narrower. If you made the course a little bit narrower, when I get up here, there's no zigzagging I can do. I've got to go over the wall. So the last thing that you could change about the obstacle course is you could change the width of the obstacle course, and that would make it more or less difficult to get through the obstacle course. We're going to skip the one about Plinko, just because we're not going to be able to watch the clip, and I don't want people who aren't big fans of Price is Right to have no idea what we're talking about. So we'll move on to the next one that's about a river, and specifically rapids in a river, like if you're whitewater rafting. Well, in order to make a section of whitewater rafting more or less difficult, rather than putting obstacles in the way, you would put more or less rocks in the way. And an increased number of rocks would make it more difficult for you to get through that section of river rapids. Decreased number of rocks would do the opposite. You could also change the length in a similar way that you could change the length of an obstacle course. Whitewater rafting over a longer distance would be more difficult than a shorter distance. And similarly, you could change the width of the section of river rapids to also change the difficulty of that section. If we move on to an actual wire, you're not going to have obstacles in your wire. You're not going to have like big obstacles in your wire. You're not going to have rocks in your wire, hopefully. What in your wire you're going to have that are similar to those objects in the way is that something called the resistivity of the wire itself. Resistivity, not resistance. I'm going to point out again that resistivity is not the same word as resistance, but resistivity, that's just a measure of how much stuff is in the way in your wire, whether it be similar to the rocks or similar to the obstacles. It's a measure of how good or bad of a conductor that particular material is. So the next one, similar to length, and length is, you guessed it, the length of your wire. A longer wire would be more difficult for the electrons to travel through, the same way that a longer obstacle course would be more difficult for people to travel through. And the last one, we have width and we have width, but wires aren't really two-dimensional. Wires are generally cylinders. So rather than having the width be what is similar to the width in this case, is we have something called what's known as the cross-sectional area of the wire. And what the cross-sectional area is, cross-sectional area, if you imagine taking a wire, kind of snipping it. If you take a wire, kind of snip it, and look head-on at it, that area is what we're talking about in terms of the cross-sectional area. So a very, very thin wire that's a cylinder that looks like this can have a small cross-sectional area, whereas a very, very big wire will have a bigger cross-sectional area. And it's just the area of the circle that would be formed if you took your wire and kind of cut it with a pair of scissors. The symbols there, the symbol for resistivity is, strangely, the Greek letter rho. The symbol for length is the letter L. That one makes sense. And the symbol for cross-sectional area is the capital letter A. That one also makes sense. We're going to use those three terms to try and come up with an equation for the resistance. Again, not to be confused with resistivity, but the resistance within a certain portion of a wire. And what the resistance is a mathematical quantity that describes how difficult it is for charge to flow through a wire, or part of a wire. The bigger the resistance, the slower the electrons will flow through that part of the wire. So one thing that I think would be directly related to the overall resistance of the wire is that measure of the resistivity, or how good or bad a certain material is at conducting electricity. The higher the resistivity, the worse the material is at letting electrons pass through it. So if the resistivity went up, the overall resistance would go up as well. Another thing that would be directly related to the resistance is the length of the wire. And a longer wire is harder for the electrons to travel through than a shorter wire. And what would be inversely related is the cross-sectional area of the wire. A thicker wire, or a wire with a bigger cross-sectional area. If you think about having a bigger wire, there's almost more room for the electrons to kind of maneuver in the wire. Therefore, the overall resistance would decrease. In terms of units, the unit for resistivity is the ohm times a meter. And if you weren't here, or if you're in third block, you've never seen that symbol for ohm before, but there you go. It's an ohm times meter. The symbol for, or the unit for length, is the meter. And the unit for area is meters squared, because you're talking about, again, the area of a circle. You don't have to square the A in the equation, it's just the unit on that is meters squared. That makes the overall unit for resistance the ohm. One final thing before we kind of just say go and you guys work on the practice problems is there's a chart of resistivities at certain temperature. And the higher the resistivity, the higher the resistance. So on this chart, the two values that have the highest resistance are tungsten, it looks like. Tungsten has a resistivity of 5.6 times 10 to the negative 8 ohms times meters. And the highest one on there is nichrome, which has a value of 150 times 10 to the negative 8 ohms times meters. The lowest resistivity, or the best conductors, or what you would want your wires to be made out of if you wanted wires to be good conductors. The values for that are copper has the lowest resistivity, therefore the lowest resistance, and copper has the second lowest resistivity, silver has the lowest resistivity. So in the equation questions below, dealing with, if it says, like, for example, the material is aluminum, you always know the value for rho. If you are given the material, it tells you that the value for aluminum for the resistivity is 2.82 times 10 to the negative 8 ohms times meters. So you can use that with the other ones in order to determine the resistance. At this point, try out that next set of questions, then check your answers with mine and send any messages if you've got questions.